In this example, I want to go ahead and take a look at how we can manage a Linux EC2 instance. And specifically, I want to launch an EC2 instance and then set up a development environment on my local machine that can then interact with the EC2 instance so that I'm not doing development on my Linux server. Instead, I'm doing development on my local environment. So the first thing I'm going to do is just kind of point out a few things with EC2. So if I were to launch an instance, when I launch an instance, this is considered an on-demand instance. So the pricing for an on-demand instance, so if I go ahead and launch an instance, so the on-demand instance is going to have additional costs associated with it versus if I would prepay for an instance. So if I choose Ubuntu, so it's my preferred Linux environment. So I choose Ubuntu. And then the instance types, you'll see that it's free tier eligible, but then they charge me hourly. Okay, so you'll notice that it's, 1.34 cents per hour. So if I go out to a calculator and I say that it's 1.34 cents per hour for 24 hours a day, so each day is going to be 32 cents, right? And then I multiply that by 30 because it just kind of average out to 30 days in a month. We're looking at like $9.65 a month for running an EC2 instance just continuously. Okay, versus if I were to go back to EC2 and I look at reserved instances. Okay, so with reserved instances, I can purchase an instance ahead of time, so I have EC2 availability to me. And you'll notice that I can just kind of choose. The way this is going to work is if I choose a longer term, I'll get a discount, and if I pay up front, I will get a discount. So if I choose the longest term and I pay all up front and I search for the instance, you'll see what ends up happening is for 36 months, I'm going to get billed $103 versus the $9.65 per month. Okay, so pretty significant savings. And then you'll also notice there's the option of the class offering being convertible. So the offering class, so it would allow me to convert the instance type. So let's say I started a business and initially I didn't have a lot of web traffic, but then ultimately I do have a lot of web traffic over time. I'd be able to convert that instance. Okay, so that's the offering class, and I pay for the ability to do that. Okay, so if I'm willing to reserve an instance, then my price goes down significantly, but I lose the ability to kind of start and stop my EC2 instance. Okay, so if I go back over to the dashboard, I can launch an instance. This is an on-demand instance, so I'm going to be kind of paying that hourly rate. But what it does is it allows me to then stop the instance and then basically stop the bill from accumulating. So I can kind of pay by the hour. So if I launch an instance and I know that I'm just launching this instance for this demo, so maybe an hour or two, I can choose Ubuntu. I'm going to pay for the 1.34 cents, right, since it's an hour, or it's rounded up to the next hour. So if it's 2 hours, then I'll pay 2.6 cents, a kind of minimal amount versus prepaying. Okay, but if I knew that I was going to use this instance and it was going to host my website, then I might want to consider reserving an instance and then running there. Okay, so in order to log in, what ends up happening, so if I create this instance, so I end up launching it, what's going to happen is Amazon creates a virtual server for me, and on that virtual server, Ubuntu is installed. And on that Ubuntu installation, there's a user account called Ubuntu. Okay, so the name of the user account is called Ubuntu. Okay, there is no password associated with it. The way you authenticate is with this key pair. Okay, so the key pair login is kind of a critical thing. What's going to happen is Amazon requires my key pair to have security credentials of 400. Okay, so 400, let me just bring up Visual Studio Code here for a second. 400 for my credentials, right? So I have a new text file and I say that the credentials are 400. The way that breaks down is this first character is for the owner, right? So I'm just going to put a header here. Whoever owns the resource. Okay. The second credential is then going to be for the group associated with the resource. And then the next credential is not going to be the world, but it's going to be everyone else, right? Not the owner and not the group. And the way this works is there's kind of a key that each permission is read, write, and execute. So the read permission has a value of 4, the write permission has a value of 2, and the execute permission has a value of 1. And the way this works is when I want to assign permissions to the owner or the group or to everyone else, I sum up the permissions that I want. Okay, so in this case, the way this sums up is the owner would have read access, and then nothing else, because the sum total is 4. The group would have no access, and everyone else would have no access. This is a requirement for that key file. Okay, so the key file requires the permissions to be set this way. These are Linux permissions. This is the way it would be described. Okay. There is no Windows comp, right? So in the Windows world, there is no comparable to the Linux permissions. What it really is basically the owner of the file should only have read access. But then Windows complicates things because it has a thing called inherited permissions, and that passes down through the files and folders, the parent files and folders. So it becomes really complicated. It's not an exact match. So what I would suggest is when we're creating the key pair, we want to save it in our profile directory, and that profile directory is going to look something like this. So there's going to be your hard drive, and then there's going to be a users folder, and then this is actually a variable which is your username, right? So your username, and then the way I handle it is there's typically a .aws folder, and that .aws folder comes into play if you've ran the from the AWS CLI, if you've ran the AWS configure command, it'll create this .aws folder. I like to save my key files into this .aws folder. Okay, if you don't have the .aws folder, maybe you can create it, and then it would get reused by your AWS CLI. So it's not going to hurt anything, but that's where I keep my key pair files. Okay? And the idea there is that because it's part of your profile, so C, users, and then whatever your username is, you're the owner of the file and you have read access to it. So you don't have to worry about those permission inheritance issues that you have in Windows. Okay, so if I'm working from a Windows machine and I'm setting up a Linux EC2 instance and I create a key pair, that's the location where I want to save that key pair. So I'm going to create a new key pair. I'm going to call this my Linux demo. Okay, and key file format's fine. I'm going to create the key pair. It's going to ask me where I want to download it. So I'm going to go ahead and save it into my profile directory. And for me, I think under Documents and Development, I have an AWS folder, and this is where I will keep it. Okay, so I'm storing it on my file system in a little bit different location, but that's fine. My network settings are fine. What I'm going to do is by default, I'm allowing SSH traffic. The reason I'm allowing SSH traffic to connect to my instance is because I use SSH to actually manage the instance. If I don't allow SSH traffic, then there is no way to manage this instance. Okay, I'm also going to allow HTTPS traffic, and ultimately I'm going to want to allow HTTP traffic, but I'm actually not going to check it right away, and the reason I'm not going to check it right away is I want to show you how I can modify it after the fact if I forget to check this. Okay, so I'm going to leave that unchecked for the time being. By default, we're getting 8 gigs of storage. Okay, 8 gigs of storage for a Linux instance is generally fine. There is some disk space available for you. On Windows, you get a default of 20 gigabytes of storage. So if I was going to set up a Windows instance, I'd get 20 gigs of storage. And 20 gigs is really light on a Windows instance. And the reason why it's really light on a Windows instance is if I apply service packs or Windows updates, it creates a lot of files and it doesn't actually clean up those files after the install. So that file system just grows and grows and grows just from the traditional Windows install. Okay, but with Linux, the install is fairly minimal in terms of file size. Okay, I think this is all ready to go. So the only thing I really configured was I did create a key pair, and then I did allow HTTPS traffic from the internet. Okay, and I'm going to go ahead and launch the instance. Okay, so if I go back to the dashboard, now I should have an instance. Okay, so there's instances and instances that are running. So here's my instance, and eventually that status will be running. You can see that it is running. Okay, so this is the instance that I'm dealing with. Okay, and I can connect to this instance and manage it, and the way I'm going to connect and manage it is with an SSH client. Okay, my SSH client, since I'm using a Mac, is my Mac terminal. If I was using Windows, I could use PowerShell or a Windows command prompt and use those as my SSH clients. But those are my SSH clients that I would use to connect to this instance. The one thing I will say is that I have a public IP address. So here's the public IP address. I can use that to connect to this instance, or I can use the public DNS address. Either one is fine. Okay. If I take this IP address and I go out to a browser and try to see that IP address, okay, eventually what's going to happen is it's going to time out. And that's me copying and pasting this IP address. If I open the address, you'll notice like down in the status bar at the bottom of my screen, it's trying to actually open that address with HTTPS. HTTPS requires an SSL certificate, and for us to install that. So for the time being, we're not going to use that, but we are going to run into issues using HTTPS. So I literally just copied the IP address and pasted it into a browser. And eventually it's going to time out. You can see it's kind of spinning here. It's not answering. The reason it's not answering is twofold. The first issue that we have is that we didn't configure this instance to allow HTTP traffic through the AWS firewall. Okay, so Amazon's getting involved in saying, you actually can't make that HTTP request. So it's not going to pass it through to my instance. The second issue that we have is even if we didn't run into issues with the AWS firewall, the second issue that we'd run into is if it passed through, so AWS's firewall's out there, and it passed through the firewall and made it to our actual instance, what would happen is we'd get to the instance, and then the instance doesn't have a web server installed. So we'd make that HTTP request, it would end up at our instance, but our instance doesn't handle HTTP requests. So our instance is not set up or configured to handle the HTTP requests because it's not a web server. Okay, we haven't installed any software to actually handle HTTP requests. Okay, so let's take care of those two issues first. So the first issue that I want to address is fixing the firewall. Okay, the way we're going to fix the firewall is for this instance, if we scroll down, there's a security tab. The security tab tells us the inbound rules. So by default, SSH traffic on port 22 is going to be fine. That can come through. And then secondarily, HTTPS traffic can come through the firewall. And that's configured. Okay. We want to configure it so that HTTP traffic, port 80, can come through. So I'm going to go ahead and click on this security group to modify my inbound rules so that I allow port 80 to come through. I could have checked this when I initially launched it and port 80 would be here, but I didn't, just to show you that after the fact I can come through and modify this. So if I click on the security group, Here's the inbound rules that I have in place. So SSH and HTTPS are fine. I want to edit the inbound rules. And what I want to do is I want to add another rule. So I'm going to add another rule which allows HTTP traffic to come through. And that HTTP traffic is going to come from anywhere. And I'm just going to save those rules. Okay, so now I can see in my security rules that I'm allowing all three of those different sources of traffic to come through, either SSH, HTTP, or HTTPS. Okay, so I've handled the first issue, which is I'm going to allow that traffic to go through the firewall. It's going to pass through the AWS firewall. It's going to make it to my virtual machine that I have, my EC2 instance. So I've fixed one issue. So the traffic will get through the firewall. The problem is once I get through the firewall and I make it to my EC2 instance, my EC2 instance is not set up to actually respond to an HTTP request. I don't have a web server installed. Okay, so what I want to do is I want to connect to my EC2 instance and install a web server so that it can respond to HTTP traffic. Okay, so I'm going to go back over to my instance. Okay, so this is my instance, and I'm just grabbing the IP address here. And what I'm going to do with that IP address is I want to use it to make an SSH connection. Okay, so if I click on this connect button, it kind of gives me some details about that SSH connection. So if I go over to my SSH client, it says to open an SSH client, locate your private key file, make sure that that key file's permissions are set to 400, and then you can connect to the EC2 instance. They actually give you an SSH connection example. Okay, so if I copy that and I go out to my terminal window, and it doesn't look like I have a terminal open, so I'll open up a terminal window and I'll clear the screen. I can use SSH to try to connect to that machine. And I'll say yes, I do want to continue. And you'll notice that I get a permission denied public key. And the reason for that is because when I try to include this public key file, I'm not actually in the current working directory. That key file doesn't exist in my current directory. If I print my current working directory, that key file doesn't exist there. Okay, where that key file is actually located is in my documents, development, and it looks like development is lowercase, and then there's an AWS folder. Okay, and now if I do a directory listing, I would see that key file. So if I do an ls of all the key files, I have a couple of different key files, but this Linux demo is one of the key files that I care about. Okay, so now if I clear the screen and I try to run that same command, the command that I copied, I'm in the current working directory where that Linux demo.pem file exists, and now you'll notice that I am connected. Okay, actually it looks like it failed. It says the private key file the permissions are too open. So what I have to do is I have to modify those permissions. So I'm going to do a sudo chmod 400. So I'm running the chmod command as an administrator, and I want to change the permissions of that Linux demo.pem file. Okay, now that I've done that, now I can actually run that SSH command and connect to that virtual server, that EC2 instance. Okay, so now I'm connected to the EC2 instance, and what I want to do is on this EC2 instance, I want to install Apache as my web server. So Apache is going to be my web server, so the command to do the install, I actually do it from the tool called apt. So apt is the tool. I want to run the command install, and I want to install Apache 2. And if I try to run this command, it's going to fail. Okay, so it fails, basically giving me a permissions issue, saying, hey, you don't have permission to do that install. So as I was saying when we initially set this up, AWS and Amazon set up a new Ubuntu instance. It installed Ubuntu on this virtual server, and it created a user account called Ubuntu. So I'm just going to blow up the font a little bit. I can see that from the prompt, right? So it's basically saying I'm logged in as Ubuntu at that IP address. So it has, I'm using that Ubuntu user account. When I ran that SSH command, you'll notice that it's saying I'm going to connect using the Ubuntu user account. That's what that connection's actually stating. Okay, so I'm connected as the Ubuntu user account. The Ubuntu user account doesn't have permission to do the install. But the way AWS configured this was it creates the Ubuntu user account that doesn't have permission, but it does have permission to run commands as an administrator. Okay, so I can run that same command as an administrator if I'm logged on as Ubuntu. The way I do that is I use sudo in front of it. So basically that means run the command as an administrator, run the command as root. And then I can type out apt install Apache 2, or the shortcut is I can use ! To indicate that I want to run the previous command as the administrative account. And now you'll notice that it is able to kick off that install and do the install of Apache. Okay, and then once this completes, we've actually handled the issue that we were running into where when we went out to a browser and we typed in the IP address, we weren't able to see a response. The first issue was we had to be able to pass through the firewall. We fixed that already. Now we are able to pass through the firewall, and now because we've installed Apache, now we have a tool on the web server. It's essentially like a service that runs in the background that we've configured to respond to HTTP requests. So now when we refresh this, now you'll notice that our EC2 instance does respond to HTTP requests. Okay. This is the Apache splash screen, and it gives us some information like you should replace this file and where it's located on the file system, and then it gives us information about how the web server is configured. What I really want to focus on is modifying this file, this HTML file. Okay, so this is the file, this splash screen, and I want to focus on how we actually modify it. Okay, so if I go back out to my terminal window and I change my working directory to var www html and do a directory listing, you'll see that index.html file. Okay, so it's on this machine. I should be able to use a tool like Nano to modify it. So if I use Nano and I try to modify index.html, one thing you'll notice is like this is the file that's getting rendered, but you'll also notice this message saying index.html is not writable. It's unwritable. And the reason why it's unwritable is because of the permission issues that we have. Okay, so if I exit out of this, I can actually look at the permissions of index.html. And the way I'm going to do that is I'm going to do a directory listing, ls, and then I'm going to use this flag -al to show the permissions of that file. Okay, and what it's going to show me is that the root user account is the owner of the file. Root is the group that's associated with the file. And this is just some Linux background. The way this is set up is when a user account's created, so the root user account is created, it also creates a corresponding group with the exact same name, so root is actually a group, and then the one member of the root group is the root user account. Okay, so essentially these two things are the same. There's a user called root, there's a group called root that has one member, which is the user root. It's kind of confusing, but that's the way it's set up. Okay, so this is the owner, this is the group, and then the permissions, remember when I was talking in numbers, and when we were talking about permissions of 400? Okay. The way this is actually set up is that there's actually a flag. So in this case, for the owner, if they're able to read, you'd see the R and then dash dash. And then for the group, you would see dash dash dash, and everyone else you would see dash dash dash. Okay. In this case, though, when I'm looking at that index.html file, I'm seeing that the owner can read and write, but they can't execute. That's what that third dash is there for. And then the group can read but can't write or execute. And then everyone else can read but can't execute. Okay, so the only person that can actually change this file or write to the file is the root user account. Okay, so I can actually modify it here. So if I'm logged in to the server as Ubuntu and I'm working through it through an SSH client, I can actually open that file using nano as an administrator. And the way I do that is I use the command sudo and then nano index.html. Okay, so now I'm saying open nano as an administrator with the file index.html. And because I'm the owner of the file, if I'm running this command as root, then I'm going to be able to modify it. Okay, so right now, if I go look at that file, you'll notice it's the Apache 2 Ubuntu default page. It works. I'm going to go ahead and change it. So I'm just going to scroll down to where I find the title. Okay, so scrolling down a ways. And then eventually, it looks like I scrolled past it. Maybe the title's way up above before the styles. I just feel like the title's kind of easy to see. So right here, I'm just going to go ahead and modify this to Brian's title. Okay, and then the commands that I can use are down below. So Nano has a tool called write out, or a command called write out. That's their version of save. So I'm going to hit Control O. It's asking, do I want to keep the name index.html? I do. So it writes out those files or saves those files, and then I can exit using Control X. Okay, once I've made that change, now you'll notice that the title's changed. I'm able to modify that file. I would argue that this is not how I want to work. What I would like to do is I'd like to be able to go over to Visual Studio Code, and I would like to be able to basically work on my local machine and then push those changes from my local machine out to the Ubuntu instance. Okay, that's the goal. So on my desktop, so if I jump over to my Finder window, I have an EC2 demo folder. I'm going to go ahead and open that in Visual Studio Code. And I don't want to save these changes, so I'm going to throw them away. I'm going to create a new file here. I'm going to call it index.html. And then because I'm working with an HTML file, you'll notice that the language mode is HTML because of the file extension. Then I'm going to have my code snippets or my code abbreviations. I'm going to make an HTML5 page, and I can change the page title. So Brian's page title from my local machine. And then down in the body, I'm just going to have an H1 tag, hello world, right? So something really simple, and I have some case issues, but I don't need to do any type correcting. Okay, so I have this HTML page that I want to move over to my EC2 instance. Okay, the tool that I use to do that is actually called SCP. Okay, so the way SCP works is it's basically going to say, I want to do a secure copy. That's what SCP stands for. And then there's some syntax associated with it, a lot like SSH. So I'm going to show you that. I'm just going to go out to a web browser, and there's a website that I always look for. So I do a search for SCP syntax. And then this is the website that I use for the different examples of things that I might want to do using SCP. Okay, so with SCP, there's a couple of examples. So in this example, they're trying to say copy a file named foobar.txt from a remote host to a local host. It's a little bit confusing, but that's the opposite direction. Like, I don't want to copy a file from my EC2 instance to my local machine. I want to do the reverse of that, which is actually the second example. I want to copy a file from my local machine out to my EC2 instance, which is the remote host. Okay, so they give you this example, and it's basically SCP, your file name, and then your username, which will be Ubuntu, at your remote host name, which will be your IP address, and then you have to say where you're copying it on that remote machine. Okay, so let's try that. Okay, I'm actually going to open up a new tab. I can't actually run SCP when I have an SSH connection. Okay, so I'm going to open up a new tab. I'm going to change my working directory to my desktop. And then I think I called that EC2 demo. And in there, there's the index.html. So the command that I want to run is scp index.html. I want to use my username, Ubuntu, at my IP address. So here's my IP address. Okay, and since this is SCP, not HTTP, I actually do not want this HTTP in front of the IP address. That's going to cause problems. So I just want the IP address. And then I have to specify where I actually want the file to be copied to, the destination on the server. So I put that colon in place, and I want it to go into the var www HTML directory. Okay, that's how I'm going to copy it over there. Okay, and if I try to do this, you'll notice that I get an error, permission denied public key. So what this is actually trying to do is say, using the Ubuntu user account, copy that file out to my destination. Well, the problem with that is I have to include that key file. The key file really includes my credentials. Okay, so the command that I actually want, I want that scp command, that's fine, but I have to include that key file. Okay, so the way I'm going to include the key file is with a -i, and then I have to specify the path to my key file. So for me, the key file is in my profile directory. That's what the the tilde/ is indicating. And then it's in my documents directory, in the development folder. There's an AWS folder, and then I believe I called it Linux demo.pem. So I'm including that key file. Okay, and now I'm getting a little bit different error. So the error I'm getting is not a permission denied public key, I'm just getting a permission denied error. Okay, and this permission denied error is a little bit different because now I am including the public key, but where I'm getting a permission denied is if I go back over to my SSH client. Remember that I actually can't modify index.html unless I'm running the command as an administrative account. Okay, so right now, index.html is locked down when I try to use the Ubuntu user account. But if I were to use the Ubuntu user account to run the command as an administrator, it'd be fine. Well, the reality is I can't do that from SCP. Okay, so if I actually want to copy the file, I'm going to have to change the permissions on my virtual server. Okay, so let's go ahead and change the permissions. So right now, if I look at that file, index.html, the root user account's the owner, and the root user account is the group associated with it. I'm actually going to go up a level and look at the HTML directory. So if I look at the HTML directory, I have the same kind of issue. Root is the owner and root is the group. And the way that works is that the root user account can read, write, and execute. But you'll notice the write permission is missing for the group and for everyone else. So the way I describe these permissions is 755. Okay, so 7 because the owner can read, write, and execute. We're adding 4 and 2 and 1. 5 because the group can only read and execute. They're missing the write permission. So just the 4 and the 1. So 755 is how I describe those permissions. I really, what I want to do is I want to change the group to a group of web developers. Okay, in order to do that, I have to actually create a group. So I'm going to do a sudo group add web devs. So I'm creating a new group called web devs. Okay, so the group should be added. And what I want to do is I want to take that web devs group and make that the group that's associated with the HTML folder. So I'm going to do a sudo change group, and I always have a hard time remembering the order, so I don't know if I want to change the group of the folder to web devs or the web devs to the folder. So I think I want to change the group to web devs for the folder HTML. Okay, and I can do that. So if I do a directory listing, you'll see that that change actually took place. But that change did not take place to the files underneath HTML. Specifically, it didn't take place to the index.html file that we actually want to modify. So usually what ends up happening is I want to run that change group command recursively to all the files and folders nested underneath it. Okay, and now if I go into that HTML folder and do a directory listing to see the group associated with index.html, you'll see it's web devs. Okay, so I'm going to change my directory back up, right? And if I do that directory listing and look at the permissions, that looks okay. But right now the group can't actually write. The group can only read and execute. Okay, so the next step of this is change it so that the group can write. Okay, so I'm going to go ahead and change the permissions to 775. So both the owner and the group is able to read, write, and execute, and only members that are not the owner or part of the group would be then locked or not have the ability to write. So I'm going to do a change mod to 775 of the HTML folder. And again, the same thing here is I don't want to just do it to the folder, I want to do it to the files underneath the folder as well, so I'm going to do that recursively. Okay, and now if I look at the permissions, now you'll notice that both the owner and the group have that read, write, execute permission, and only the members that are not the owner and not part of the group are blocked from actually writing to that file. Okay, so now if I go into the HTML folder and I look at the permissions, you'll notice index.html is set up the same way. So right now I'm logged on as Ubuntu. Theoretically, I should be able to modify index.html. So if I open up index.html using nano, you'll notice it's still saying it's unwritable. Okay, so that permission still hasn't taken effect. Okay, and one of the reasons it hasn't taken effect is because this Ubuntu user account doesn't actually belong to the web devs folder or to the web devs group. So what I want to do is I want to add that user. I can't remember the command to add a user to a group. Linux add user to group. And it's really easy. So group add, new group, we've already done that. And then we want to add the user with the username to the group name. Okay, so I'm going to do that. Sudo add user Ubuntu to my new group name, which is web devs. Okay, so now that's happened. So now theoretically the Ubuntu account has access to modify index.html. So if I try to use nano, you'll see it's still not writable. I think everything is configured correctly right now to allow Ubuntu to modify that file, but that change doesn't actually take effect until I log out and log back in. So I'm actually going to exit, and then I'm going to reconnect. Okay, so logged out, logged back in. I'm going to change my working directory to var www.html, and then I'm going to try to use nano to open up index.html, and you'll notice that that message about it being unwritable is gone. So now I can say that Brian's title can be changed. Okay, I'm going to use Control-O to write it out, confirm that I want the file name to be index.html, and then I can exit. Okay, and now if I go back over, you can see that my title will change when I refresh the page. Okay, so now that my Ubuntu account has the ability to modify index.html, now if I jump back over to that scp command that wasn't working, this permission denied was because my account didn't have write access to modify index.html. So now if I try that scp command again, now you'll notice that the file gets copied out to that server using scp, and now if I look, I'm replacing the default page with that scp command. So now I get hello world, and you'll notice that I get my page title from my local machine. Okay, so I'm able to set that up. Okay, so there's a lot of moving pieces here. The first thing we did is we installed a web server, so we installed Apache, and that allowed us to respond to those HTTP requests. Once we're able to respond to those HTTP requests, we had to modify some permissions to allow our user accounts to work with that HTML directory, and then specifically the files within the directory. Okay, and then once we set that all up, then we were able to then move our files from our local machine out to our EC2 instance. Okay, and the way we did that is with scp. Okay, and the way I got to the syntax for scp is I just did a Google search for scp syntax, and I always use this website, and hypexr or hypexr. If I go into that, then it has examples of things that I might want to do, like copying directories, copying files, downloading files, things like that. The only thing I will suggest here, though, or mention, is that this scp syntax is not complete. I do have to use that I flag to include the key file that's going to allow me to pass my credentials through, and that's more of an AWS thing than an scp thing. Okay, so because AWS is using those key files for credentials, I do have to include the key file in order for this scp command to work correctly. Okay, so that's just a general overview of how I would set up a web server and then move files from my local machine out to that web server.